Hi, we are Team Fire Drones from Houston Community College. Today, we are revolutionizing wildland firefighting through autonomous drone technologies. Let's start with the problem.
Have you heard about the Smokehouse Creek wildfire that happened recently in Texas? It was a massive record-breaking wildfire that caused about 1.3 million acres of land to be destroyed. To put that into perspective, 1 million acres of land is a little more of two states combined. Could you try to imagine how much of the damage this area may have caused? According to the UN, 7.2 million acres of land are burned annually. Due to climate change, fires are becoming bigger and more frequent as time passes by. In addition, aerial firefighting job is very dangerous. This is because there is limited visibility due to smoke, pilots fly lower to the ground due to aerial jobs. There are fewer workers joining the firefighting industry, and there is limited time for fighting wildfires. On average, wildfires are about 6 hours in the day and not at all at night. If wildfires were fought at night, then this tragic event would have been prevented. A woman named Owen, while driving back from work, got caught up by a fast approaching fire and died due to it. Our drones could have stopped this from happening.
And we have the solution. This, an autonomous fleet of drones which utilize NASA technologies to fight wildfires day and night and make aerial firefighting safer, more efficient, and time effective. We have many benefits, including safety. Our drone is safe because we pick pilots out of harm's way. We are also cost effective due to the drone simplicity of our design. And also, with train time is reduced thanks to autonomy, we can reduce the train time in half. Lastly, we are scalable because instead of one pilot controlling one aircraft, at Fireguard drones, you can have multiple pilots controlling multiple aircraft. How do we use our technology? We utilize NASA's UAS traffic management IP TOPS 2-237 to safely and efficiently coordinate within the wildfire airspace. Also, we utilize their safety dish technology to provide a list of safety critical features for our drone to perform in case of an emergency. Our drone has many features, starting with what's in blue, our water tank. Our water tank can hold up to 150 gallons of water, firefighting retardant, or foam. And we can refill all of that with under 30 seconds. Also, in the green, we have our sensor technology, which consists of our thermographic camera set that we can see through the smoke and GPS that we can navigate. This allows our drone to coordinate within the airspace and see and avoid other hazards like trees, mountain ranges, and other aircraft. In yellow, we have our engine. It is a 400 horsepower engine and has an aviation fuel tank of 40 gallons, which gives our drone the performance and the endurance of up to 1.5 hours. Also, in the red, we have our emergency technologies, which is where a lot of our safety features will be implemented. Lastly, in the black, we have our coaxial rotor mechanism, which consists of the 2 counter-rotating propellers, and this makes our drone more efficient and more powerful than traditional helicopters.
Our UAS system follows 4 steps. First, launch, where a fleet of 5 drones take off from the airbase of a nearby fire department. Second, our UAS system which cruise to the scene using NASA's UAS traffic management system for safe and efficient airspace coordination. In addition, we will use NASA's safety dish IP to land safely. Next, our UAS system will refill at 150 gallons of water within 30 seconds. Within 30 seconds, add a body of water using a retractable hose. We plan on entering 2 main markets. The first is the drone market, which is a $19.89 billion market and has a 13% compound annual growth rate. The second is the wildfire management market, which is a $2.6 billion market and is expected to grow to 3.6 by 2028. We have 2 phases of our market strategy: testing and deploying our product to our customers. We plan on testing with NASA's Airborne program, which is a wildfire fighting technology maturation program. We also plan on testing with the Forestry Protection Service. We have 2 main target customers: the U.S. and Federal Forestry Protection Service and local fire departments.
So now for a quick look at our product development timeline over the next 4 years. So from 2024 to 2025, we plan on testing our autonomous software and swarm technologies. From 2025 to 2026, we plan on validating our drone concept with the coaxial design. From 2026 to 2027, we'll have the first commercial model available, do some flight tests as well as test and control burn scenarios. And finally, by 2028, we'll begin launching and rolling out for commercialization and begin our FAA process for approval. So now let's do a quick SWOT analysis: strengths, weaknesses, opportunities, and threats. For strengths, our main strength in our autonomous software and swarm technology. For weaknesses, we are aware of any new technology, there will be a bit of a learning curve or adoption curve. So we plan to combat this with an SOP or standard operating procedure to help smooth out the transition. For opportunities, this is a brand new market for fire suppression, as well as we are utilizing the U.S. ban on foreign drone manufacturers, which will allow us to thrive in the U.S. Finally, for threats, we are aware of the possibility of FAA intervention. We plan on working closely with FAA to ensure we get the necessary approval. After testing, we plan on manufacturing and scaling. And to do this, there are 3 key aspects to make our business model work, being inventory management, machine and equipment costs, and finally, getting key hires. So for inventory, we plan on getting various parts, such as lithium-ion batteries, flight controllers, and the turbine engine. For machine and equipment, we plan on, for a flat fee of about $600,000, we plan on getting CNC machines, laser cutters, and finally flight simulation software for R&D. And finally, for key hires, we plan on getting software developers, electrical and mechanical engineers, and quality control inspectors to ensure we not only meet the industry standards, but exceed them.
Now let's quickly touch on the competitive analysis. Compared to big competitors in the firefighting industry like the Firehawk, the Chin CH-47, and Bell 206, we have biggest advantages in operations, training, and price. Our drone can operate day and night, autonomously, safe, while other helicopters must be piloted and controlled during the daytime for maximum visibility. Our training is half compared to the 12-month standard. Our estimated selling price is $250,000, while other helicopters sitting around at more than $1 million per machine. On a one-to-one comparison, our drone system outweighs the other helicopters with a swarm system. For example, one Bell 206 costs around $900,000. Imagine at the same price, 3 5 drones can be deployed to deliver 300% more water, and against the Chin CH-47, 145 drones can be deployed to deliver 722% more water just at the same price. With these potential, fighter drone is a revolutionary technology in wildland firefighting to solve current problems. Call fighter drones your first response against wildfire. Thank you.
Thank you for that presentation. That was an interesting idea. One thing